Welcome, this is using trig ratios to find an angle. Here the learning target is for you to actually use the inverse trig ratio to solve for an angle. Your two success criteria is can I construct the trig ratio with your known variable, then can you apply the inverse trig ratio to find the angle. So before we go to today's lesson, I would like to review what we did prior to this, which is like this problem. We had a right triangle and we were trying to find the lengths. So we did our trig ratios. So my question to you is this. What was our goal when we set up the trig ratio? Why did we use sine, cosine, and tan? What were we trying to get? What were we solving for? The answer. We used the trig ratio to solve, find, or get a missing side of the right triangle. Here the value of x was a side or a leg of the triangle, and y was another leg or side of the triangle. So we saw that this whole process here was trying to get a missing side for the right triangle. That's the whole purpose of sine, cosine, and tangent, is used for us to get the sides of a right triangle. Now the question is this. How can I get the angle now? What about if you have the sides, but now you want the angle? This is how we get the inverse trig ratio. The inverse trig ratio is used to solve, find, or to get an angle of the right triangle. Before, we wanted the sides, so we used the regular sine, cosine, and tangent. But now, we're going to use the inverse to find the angle of the right triangle. And here are your inverses. So, looking at it from the point of view of angle A, we would say that the angle A is equal to sine, and this -1 in the air is your inverse. So you could call this sine inverse, or inverse sine, is equal to the opposite over hypotenuse, which is the same way as before. You could also say that angle A is equal to the inverse cosine with of adjacent divided by the hypotenuse. And you could also say angle A is also equal to the inverse tangent of your opposite divided by your adjacent. Notice that the ratios here are the same. Sine is still opposite over hypotenuse, cosine is still adjacent over hypotenuse, and tan is still opposite over adjacent. Now let's see this core concept in work in a problem. What I would like you to do is match it up with each inverse trig ratio, matching it up with each of its triangles. So here we are looking at it from all the point of view of angle A. We saw that 17.6 is our adjacent, 11 is our opposite. We put the guy here on angle A. 61 is our opposite. 6.1 is our opposite. 14 is our hypotenuse. For the third triangle, we put the guy here on the A. We saw 12.6 is your adjacent, and 14 is your hypotenuse. So now you can match it up. Which one has a adjacent and opposite? That is going to be your TOA. Which one is going to be opposite and hypotenuse? That is going to be your SHOA. Adjacent and hypotenuse is going to be your CA-TOA. Right? CA, C-H-A. So let's see if that works. That is correct. To find angle A here, we would use inverse tangent of opposite over adjacent. Here, to find angle A, we have to use the inverse sine because we have opposite over hypotenuse. Then cosine, the inverse of cosine for your adjacent over your hypotenuse. Okay, I just want you to make sure that you know which inverse trig ratio to use based on the situation. Now I'm going to show you an example. The question: find the angle measurement of angle A, round to the nearest whole number. You should notice there is a missing angle here. You don't know it. So I'm just going to draw our guy here, and we don't know what it is. But we know 17 is our adjacent side based on the person's on angle A. And we know 11 is our cosine. Here's our solution. You should notice you're going to use the inverse tangent because you have your opposite and your adjacent leg, which is your TOA. So all you have to do is put that in. Angle A is equal to the inverse tangent, parentheses opposite over adjacent. So it should look like this. You plug it in. 11 goes in for the opposite, and the adjacent is 17.6. I'm going to pull up Desmos so we can plug this in. Okay. Just to let you guys know, all I search is Desmos Scientific Calculator. It's right here, Desmos Scientific Calculator. All right. So now I'm going to enter this in. So tan inverse. Can I press just tan? No, you want the inverse one. Okay. So let's look for it. Function right here. So you would have to hit function, right? FUNC, and the tan inverse is right here. It has the -1. Now you want to do 11. Then we hit the divide symbol. Okay. And 17.6 is on the bottom, and our answer is going to be 32 degrees. Okay. There you go. So we could say that angle A is equal to 32 degrees. That's the 32 degrees there. I would like you to understand the similarities and differences. Today's problem was this. We used the inverse tangent to find the angle measurement of 32. The lesson before this, we did the exact problem, but we looked for x, and we saw that x was 17.6. What I would like you guys to notice is that you're using the same trig ratio. One is you're using the inverse trig to find the angle, but you're using the regular trig version to find the sides. But it describes the same triangle. Now, let's do this. This is time for you to practice finding the angle measurement of angle A. Number 1 and number 2, please do that. Let's just label that first. We have from the angle point of view of angle A, so we draw our person here on angle A. We saw 6.1 is going to be your opposite, 14 is going to be your hypotenuse. Here we draw the person here again on angle A. The leg here is going to be your adjacent leg, and 14 is going to be your hypotenuse. So opposite over hypotenuse is going to be your Showa, and adjacent and your hypotenuse is your CAH, right? Shokatoa, yeah, Ka, CHA. All right, here's your solution. Again, you're trying to find the angle, so you're going to use the inverse sign because you have the opposite and the hypotenuse leg. There you go. Sine inverse is opposite over hypotenuse. Sine inverse of 6.1 divided by 14. Let me pull that up on Desmos for you. Again, hit the function symbol so you can get the inverses. Hit sine inverse, 6.1 divided by 14. You should get the value of 25.8. If I round it up, that gets me 26. The next one, I'm going to use my cosine. I'm going to use my inverse cosine because I have my adjacent leg and my hypotenuse leg. I would say that angle A is equal to inverse cosine, adjacent divided by the hypotenuse. The adjacent leg here is 12.6. The hypotenuse is 14. Angle, now I plug this into Desmos. Hit the function symbol so you can get cosine inverse. 12.6, divide that by 14. You also get 25.8. Round that up, that becomes 26. Please notice, number 1 and number 2 actually solve for the same angle measurement, but it depends on what you have. Again, if you have the opposite and hypotenuse, make sure you use sine. And if you have adjacent and hypotenuse, make sure you use cosine. Now, let's look at this example. Okay, you already have that this angle is 26, but now you need to know the other angle. So you're missing Angle B. You need to know this. This is your unknown. This is your question mark. How do you go about that? Well, there are two approaches. Method 1, just use your inverse trig ratio again. You saw that from angle B's point of view, 6.1 is going to be your adjacent and 14 is your hypotenuse. So you're just going to use your cosine inverse. Okay, cosine inverse cosine is 6.1 divided by 14. Plug that into decimals, you get 64 degrees. Or you can use method 2. Notice that the inside of any triangle adds up to 180 degrees. You have 26. The red box here means 90. Okay, so 26 plus 90 plus angle B is going to be equal to 180 degrees. 90 plus 26 is 116. Subtract 116 to both sides. What did you get? You get subtract 116 to both sides. You get angle B is equal to 64 degrees. Notice, either way you get the same answer. Good? All right. Next. Like before, I would like you to solve for the right triangle. Go ahead. Let's do the first one. Here, I'm going to look at it from the point of view of E. So I'm going to put the guy here. I'm going to put that this is my adjacent because it's my closest one, and this is my opposite. So to find angle E, I'm going to use my TOA. No, opposite over adjacent, correct. So angle E is equal to tan inverse opposite over adjacent, which is tan inverse of 20 over 21. That gets me angle E equals to 44 degrees. Now, I'm going to switch it up. Now, I'm going to look at it from the point of view of angle D because I want angle D. So I put the person here. I saw that now 21 is my opposite and 20 is my adjacent. So I'm still going to use TOA, right? But now I write angle D is equal to tan inverse. What is my opposite? 21. What is my adjacent? 20. So tan inverse of 21 over 20 gets you 46 degrees. There you go. So again, it depends on your point of view. Your adjacent and your opposite can vary. Let's do number 2 now. Let's solve for angle H first. So we draw our person here on angle H, label what we have. 21 is our adjacent, 109 is our hypotenuse. So this is going to be COA. So solution, angle H is going to be the inverse of cosine, adjacent over hypotenuse. Sorry, that is COA, CAH. 91 divided by 109 gets you H is equal to 33 degrees. Let's look at it from the point of view of G now. We draw the person here on angle G. Notice I draw the person each time I look at a different angle. Why? Because that's how I prevent from getting the question wrong. I'm just going to label it. 91 is my opposite. 109 is our hypotenuse. Now I look opposite over hypotenuse. That is my sine, Showa. Sine is opposite over hypotenuse. So now I can set it up. Angle G is equal to the inverse of sine, which is opposite over hypotenuse. So it's inverse sine of 91 over 109. Angle G is approximately 57 degrees. There you go. So there you go. Those are all your ways to use the inverse sine to solve for a right triangle.